Good day, ladies and gentlemen. Before we start, first things first. We as a team would like to introduce ourselves to you. Our group members are Johan, Erik, Ludwig and Anrich. Now that you know the team, you most probably would also like to know what we are going to talk about in this video. Simply put, we will discuss the following topics: relational databases, object-orientated databases, the No-SQL database, and last but not least, the data warehouse. Relational database. What is meant by a relational database? It is seen as a computer database in which all data is stored in relations, which are tables with rows and columns. Now that we know the definition of a relational database, let's take a closer look. We have three tables: lecturer, class, and room. All three tables have distinct values, each with a primary key to uniquely identify each one. Then, to show how the tables are related, you can see that class contains the primary keys of lecturer and room, which in turn will make them foreign keys in the class table. This then binds the tables, creating a relation between each one. Relationships between tables can be of different types, such as one-to-one, one-to-many, or many-to-many. Let's take a look at the advantages and disadvantages of relational databases. The advantages can be seen as ease of use. The revision of any information as tables consisting of rows and columns is much easier to understand. Flexibility. Different tables from which information has to be linked and extracted can be easily manipulated by operators such as project and join to give information in the form in which it is desired. Security. Security control and authorization can also be implemented more easily by moving sensitive attributes in a given table into a separate relation with its own authorization controls. The disadvantages. Performance. A major constraint and therefore disadvantage in the use of relational database system is machine performance. If the number of tables between which relationships to be established are large, the tables themselves affect the performance in responding to the SQL queries. Physical storage consumption. With an interactive system, for example an operation like join, would depend upon the physical storage also. It is therefore common in relational databases to tune the databases, and in such a case the physical data layout would be chosen so as to give good performance in the most frequently run operations. Last but not least, slow extraction of meaning from data. If the data is naturally organized in a hierarchical manner and stored as such, the hierarchical approach may give quick meaning for that data.
Hello and welcome to our part 2 of the presentation. In the first part we looked at relational databases. In this part we're looking at the object database, also object-oriented database management system. And it's a database management system in which information is represented in the form of objects as used in object-oriented programming. Object databases are different from relational databases, which are table-oriented. Object-oriented database management systems rather focuses on the combining of database capabilities with object-oriented programming languages. Languages such as Delphi, C#, Java are used by the programmers to develop the products. So the system allows us to the product, store them as objects and replicate or modify existing objects within one environment. So the benefits are it reduces maintenance, so it enjoys a longer life while having far smaller maintenance costs. Secondly, you have your real-world modeling, whereas the real world in a more complete fashion than the traditional methods. The model is based on objects rather than data and processing. Thirdly, you have your improved reliability and flexibility. So it can build from existing objects. The new objects may inherit data attributes from one or many other objects. Lastly, you have high code reusability. When a new object is created, it will automatically inherit the data, attributes, and characteristics of the class from which it was spawned. There are a few disadvantages, such as object-oriented development is not a technology, and rather it is structures and behaviors. Object-oriented development is not yet completely accepted by major vendors. Thank you for listening to our part 2 of a presentation of the different databases discussed in this course.
Hello, my name is Ulrich and I'm here to talk about No-SQL. No-SQL database environment is simply put a non-relational and largely distributed database system that enables rapid ad hoc organizations and analysis of extremely high volume tested data types. No-SQL databases are sometimes referred to as a cloud database, non-relational database, and big databases. They were developed in response to the sheer amount of volume of data being generated, stored, and analyzed by modern users, that is user-generated, and their applications, that is machine-generated data. In general, NoSQL databases have become the first alternative to relational databases, with scalability, availability, and fault tolerance being the key deciding factors. They go well beyond the more widely understood legacy relational databases such as Oracle, SQL Server, and DB2 databases in satisfying the needs of today's modern business applications. There are 5 types of NoSQL databases, the first of which is a graph database. This is based on a graph theory. These databases are designed for data whose relations are well represented as a graph and has elements which are interconnected with an undetermined number of relations between them. Next, we have a key value store. Key value stores are some of the least complex NoSQL options. In a key value store, all of the data within consists of an index key and a value. Examples of this include like the Azure Table Storage, Riak, and Berkeley DB. Then we have the column family store. Instead of storing data in rows, these databases are designed for storing data tables as sections of columns of data, rather than rows of data. Next, we have the partitioned row store. Data is stored in tables which have a schema and are strongly typed. Rows are organized into partitions which are stored sequentially on disks to achieve high performance. Then finally, we have a document database. This expands on the basic idea of a key value store where documents are more complex in that they contain data and each document is assigned a unique key which is used to retrieve. And that concludes the NoSQL database.
And welcome to our final part of the presentation, data warehousing. So the first question that comes to mind is, what is data warehousing? Well, in computing, a data warehouse, or also known as an enterprise data warehouse, is a system used for reporting and for data analysis. Data warehouses are central repositories for integrated data from one or more unique sources. They store current and historical data and are used for creating analytical reports for knowledge workers throughout the enterprise. There are 3 types of designs used for data warehousing: the bottom-up design, the top-down design, and lastly the hybrid design. Now, starting with the bottom-up design, data marts are first created to provide reporting and analytical capabilities for specific business processes. The simplest way to explain data marts is to describe them as small slices of data in a warehouse. These data marts can then be integrated to create a comprehensive data warehouse. The term bus architecture is a framework for data marts to fit together. Data warehouse bus architecture is primarily an implementation of the bus. So now you're wondering, what is the bus? The bus is a collection of conformed dimensions and conformed facts, which are dimensions that are shared between facts and 2 or more data marts. Then secondly, we have the top-down design. The top-down approach is designed using a normalized enterprise data model. Atomic data, a data that is the lowest level of detail, are stored in the data warehouse. Dimensional data marts containing data needed for specific business processes or specific departments are created for the data warehouse. Then finally we have the hybrid design. The data warehouse in a hybrid solution is kept in the third normal form to eliminate data redundancy. A normal relational database, however, is not efficient for business intelligence reports, where dimensional modeling is prevalent. Small data marts can stop for data from the consolational warehouse and use the filtered specific data for the fact table and dimensional required. The data warehouse is a single source of information from which the data marts can read, providing a wide range of business information. The hybrid architecture allows a data warehouse to be replaced with a master data management solution where operational, not statistic, information could reside. Thank you for listening to our presentation, and I hope you now have a better understanding